Our next speaker is Yuraima Estevez. And Yuraima is a senior software engineer at the New York Times. And she's very passionate about building open source tools and empathetic web design and development. And also finding the best tacos in whatever city she happens to be in. So if any of you have strong opinions about the best tacos here, please come up and tell her afterwards. And right now, I think Leo's taco truck was what she's tried out. So if you have something better than that, let us all know. All right, Yuraima, thanks.
Hello? Is the volume okay? Yeah, all right, great. Hello, everyone. How's it going? I heard that I am the very last speaker today, and I'm basically what's keeping you from a happy hour. So to distract from that, I'm gonna start off with some very hilarious and very amazing jokes, and you all have to laugh at them. So just, laugh, audibly groan, and then you'll forget all about the happy hour. So, first joke. What did the judge say when a skunk entered the courtroom? Odor in the court. Yeah. Okay, one more. How do spiders communicate? Through the World Wide Web, yeah. Round of applause for me, yes. Okay, great. Now that the important stuff is out of the way, let's talk about accessibility. And I want to start off first by making sure that my slides work, and they do. We want to start off by talking about what is accessibility. Let's answer this question. In web development, this really means websites, tools, and technologies that are designed and developed so that people with disabilities can use them. And there are a lot of reasons why accessibility should be a priority for us as engineers, and why we need to make sure it's part of our day-to-day. Of course, there are monetary and legal reasons why we should really keep accessibility top of mind, but I want to focus on one reason in particular, because it's the one that resonates most with me, and I hope it will with you too. As engineers, we have a lot of power in shaping the impact we have on our users, and that power is at scale. Consider maybe a time when perhaps you prevented a user from being able to use your website. Let's say someone needed to pay their bills online, but they were only navigating the web using a keyboard, and they weren't actually able to go ahead and complete that form. Or maybe a user can't find out who wins the 2020 election because the page they're trying to access doesn't work with the screen reader that they're using. And that's actually one example of what the New York Times is considering this year for November. So we shouldn't be the ones as engineers that are gatekeeping or limiting access to the web. But when we aren't mindful of the code that we're writing and the users that are impacted by it, then sometimes that ends up being the result. So we want to make sure that we're keeping the web universal and inclusive, and that means that we have to make our websites accessible. And to do that, we should start with the fundamentals. Components are one of the things that makes React so powerful. They're encapsulated, reusable, and custom elements, and they allow us to package up functionality and UI and utilize them in various parts of our code bases. Essentially, they're the building blocks of our apps and our websites. And if the blocks are reliable and well built, it stands to reason that our apps will be too. So if we designed and developed our building blocks to be accessible, then I think we can start making some significant progress in making our websites fully accessible and making sure that they work for everyone. Unfortunately, that is a lot easier said than done. I remember when I was first starting out learning accessibility concepts, one of the hardest things that I had to figure out was how I could take the components I'd written dozens of times before and uncovering the requirements that I needed to make them accessible. And naturally, I thought that turning to the documentation would help clear up my confusion. Whoops, I dropped something. Would help clear up my confusion, but instead I was hit with this. Yeah, I know, we've all seen this. A huge wall of text with hundreds of links that go to even more huge walls of text, and dozens of concepts that I didn't even know that I didn't know. But of course, that did not get me off the hook. I couldn't just brush accessibility under the rug. Instead, I had to become a bit more strategic about how I was approaching the documentation. And that's what we're going to be doing today during this talk. This is me. My name is Yuraima Estevez. I am a tech lead at the New York Times. And I'm going to share my too long, didn't read, or TLDR approach to building accessible components. It's the way that I tackle building accessible components by going off of the documentation and quickly identifying the requirements necessary for actually making them work for all people. And for the most part, I've broken it down into 3 easy steps. We want to make sure that we are using Semantic HTML whenever possible. We also want to identify the ARIA attributes that we need that we can add to those HTML elements. And we have to manage our keyboard navigation within our components. And you have probably already noticed that these are my 3 easy steps, in quotes. And that's because, like any other skill in engineering, it takes time and effort and energy and experience to build up our understanding of accessibility. This is unfortunately not a silver bullet solution. This isn't a magical life hack. And these are definitely not the only things that we need to consider when we're building up our accessible websites. But I think by narrowing things down a bit, it can be a little bit easier for us to ramp up and target exactly what we need to get up and running. So let's get up and running and start with our Semantic HTML. Semantic HTML provides our content and our components with meaning beyond their visual representation. One of the things that's so powerful about HTML is that it was fundamentally designed and built to be accessible. And because of this, we can rely pretty heavily on Semantic HTML elements to do a lot of the heavy lifting when it comes to our accessibility support. And this is critical, especially when we're building our websites, because this means that these elements can be understood by assistive technologies. And we have to remember that assistive technologies are really just software and hardware, so they can only understand the code that we write. And if we want these technologies to properly identify and interact with the components that we're building, we have to make sure that we're speaking their language. Really quick show of hands, and promise no judgments, no shame. Who has ever done this? Yeah, a designer hands us a mock-up. It's a button. We think, oh, I'm going to use a div, and I'm going to slap a click handler on it, and I'm going to style it to look like a button. And for the most part, that's exactly what we're going to get. We are going to get a div with a click handler and nothing else. And that's because assistive technologies, like let's say screen readers, will have absolutely no idea that this element even exists because divs have no semantic meaning. They're pretty much just there so that we can target them for styling purposes. And on top of that, divs are not interactive elements. So if a user was relying on a keyboard to navigate, let's say, this div would not even be available to them to focus or interact with. But if instead we were using our HTML button element, we would get all of that for free. Assistive technologies understand what this is, and they know how to interact with it, and they know how to announce it to the users. And another bonus, it's fully interactive using only a keyboard right out of the box. If we wanted to, let's say, do something foolish and build out a button component using a div when we already have a beautiful button HTML element, we're gonna see that there is a lot more work that we have to put into this. So all that's to say that a lot of times it's so much easier for us to just use the semantic HTML elements that are available to us than to try and jam accessibility support into something like a div. And there are over 100 elements available in HTML, so we really have a great source that we can pull from, and we should be using those tools whenever we can. So the next time we say we want to build something like a nav bar, instead of reaching for our divs and our spans and our click handlers that navigate somewhere, we should instead reach for the HTML nav element, the list items, and anchors, and all of the accessibility support is already baked into it. And instead of trying to reinvent the wheel by styling a table out of divs, let's use the table element and just override the default styling, because these elements were built with accessibility in mind, and we should be leveraging them in the components we build whenever we can. Now, that said, semantic HTML elements can't solve all of our accessibility problems. For example, something like this. It would be great if this actually existed in HTML, but it doesn't. This is a magical made-up nav bar with a drop-down menu in it. And if this existed, we could have a drop-down HTML element, and all of its behavior would be automatically managed by the browser. And because it would be a native semantic HTML element, it would automatically be recognized by assistive technologies without any work on our part. We could have something like this drop-down HTML element and a drop-down list element, and all of the magic would just happen for us. But that is not the world we live in. Instead, we have to do all of this ourselves using CSS and JavaScript and figure out how a drop-down menu should work. But of course, one of the downsides is that this component is not accessible as is. And that's because no assistive technology is going to be able to identify this as a menu bar with drop-down menu items in it. So what we really need is a way to assign semantic meaning to our elements and components so that assistive technologies can know how to work with them. And that's where ARIA attributes come in. ARIA stands for Accessible Rich Internet Applications, and they are a set of HTML attributes that help define the semantics of an element or a component. And they really exist so that they can provide meaning to our components when they are being interpreted by something like a screen reader or other assistive technologies. For the most part, ARIA attributes are broken down into 3 categories. We have roles, which help define and identify the type of element or component. And then we have states and properties. And states and properties are supportive attributes that can be used with roles. And ARIA roles can be combined with states and properties, and together they are understood by assistive technologies, and those assistive technologies could then communicate these components to the user. And this is where I think my first very helpful W3C doc comes in handy. This is a guide with a list of different components and widgets and design patterns that we know and love all around the web. It contains a list of common components, things like alerts, our button, different links, sliders, and a whole other grouping of components. And it also has details about which ARIA roles, ARIA states, and properties are required and available to build up each of these components. And a special bonus, it also includes code samples written in vanilla HTML, CSS, and JavaScript. And we can use these as a reference so that when we are building out our components in React, we have something to work off of. So going off of these design pattern documents, let's break down the ARIA attributes that our button component needs. But before we do that, we need to have a very quick warning about the general rule of thumb for ARIA. And that is that the best ARIA is no ARIA at all, which is surprising, but hear me out, because what that means is if we have HTML elements that support what we're trying to do, we should use those instead of trying to backfill our semantic meaning with ARIA attributes. And that's because ARIA is a really powerful tool that essentially overrides all of the semantic meaning of elements once they're applied. And what that means is if we incorrectly use or implement ARIA attributes, that could have pretty detrimental effects for our users. It could render our components completely useless when it comes to assistive technology and just create a terrible user experience for the people that are using our websites. But just as an illustration, let's try and build up our div button and make it accessible. According to the docs, what we want to do first is make sure that we add the ARIA role attribute and set that equal to a button. And this is going to allow our assistive technologies to identify this element as a button and let our user know that it's an element that can be interacted with. We also want to pass in a value for an accessible label using either the attribute ARIA label or ARIA labeled by. Usually the screen reader will read the content inside of our button by default, but if we needed to override that value, we could explicitly pass in what should be announced for this button. And this comes in handy if we had a button that had non-text content inside of it, something like an image or icons or sprites. And lastly, according to the docs, we want to make sure that we signal to our assistive technology when a button is inactive. And we can do that by adding the ARIA disabled state attribute and set it to either true or false, depending on the state of our button. And I think that's about it for our ARIA attributes for this simple button. So let's take a really quick look at another component, something that we know and love, modals. We all love building modals. Yeah, I know, I'm traumatized too, don't worry. So here is a truncated version of a simple ARIA modal, or a simple modal. And we need to make sure that we are signaling to our assistive technology that this is a modal, so we're going to add the ARIA role attribute and set it to dialogue. We also need to tell our assistive technology when our modal is open and active, and we can do that by setting the ARIA modal attribute and setting it to true or false. When it's set to true, our assistive tech will know that there's a modal on the screen, it's popped up, and it's available to be interacted with or just read off. And we also want to make sure that we're providing an accessible label. So this time I'm going to use the ARIA labeled by property. And for that, I'm going to set the value equal to the ID of an element that contains the modal title. And in this case, that's my H2 element right there. I have an ID of modal title, and I'm going to set that modal title equal to my ARIA labeled by. And that is another very, very simple example of ARIA for an accessible modal. Now, we probably noticed something pretty important about ARIA attributes through those two examples, and that's that ARIA attributes function only as a way to communicate to assistive technologies like our screen readers when our components are available. What they don't do is help with keyboard interactions. But luckily, that's our third and last easy step. All of our components have to support keyboard-only navigation. And that's because not everyone uses a mouse as their primary device of navigation when they're on the web or using their computer. So unless we're solely relying on semantic HTML elements, we're entirely responsible for managing keyboard navigation of our accessible components. So we have to consider, first and foremost, how a user would be able to interact with our components using only a keyboard. And here's another easy win with the W3C docs. They outline exactly how a keyboard should be able to interact with components from our design patterns and widgets page. They have this entire section that explains which keys do what and what the common conventions are that a user that's primarily navigating with a keyboard would expect to be able to use. So let's go back and figure out how we can build up keyboard navigation for our button based on the W3C docs. The first thing we want to do is make sure that our div element, which is not interactive by default, can gain keyboard focus and be interactive. So we're going to set the tab index attribute to 0, and this is going to put our div element into the tab order flow and make it possible for our user to assign focus to that through their keyboard. We're also passing an activate function to our button, and we're setting that equal to our on-click handler, on-click handler on the div. But we also need a way to trigger our activate function with a keyboard. So we're gonna add a key listener to our button. I'm gonna use on-key press for this one. And we want to go ahead and pass in our key press handler function. And what this is going to do is check when a key is pressed. And according to the W3C docs, for a button, we want to make sure that we're keying in on the space and the enter keys. If either of those are pressed, we want to make sure that we're running our activate function, the same one that's being passed over to our click handler. And now we have a very simple div button that happens to be keyboard accessible. But there are a couple of other considerations that we have to make when we're building up our component keyboard navigation. One of them is making sure that our users know exactly where their keyboard focus is at all times. And really what this means is that we should have some kind of visible indicator for which element or elements currently have focus. And at the very least, that means that we should not eliminate or change the focus outline on active elements. So I'm sure at least at one point in your careers, someone has come up to you and asked, hey, can we get rid of that blue line that's going around the button? I really don't like that. And the answer is always no, unless you substitute it for something that is equivalent. We also want to make sure that we're creating a predictable tab order so that our users can more or less know where their focus is going to go when they tab to the next or the previous element. Then we want to make sure that we're managing focus so that it persists between interaction events. And here's generally what that means. If we take a look at this example of a modal, when I key into this modal using my button, my keyboard focus moves into the first interactive element inside that modal. When I close that modal down, now, my keyboard focus goes back to the button that activated it. And this is important because between this activate and essentially delete event, we want to make sure that our keyboard focus doesn't just drop off the face of the page. It doesn't go somewhere completely unexpected. Our user should know exactly where their keyboard focus is and where it's going to be going. And this is especially important in something like React, because React makes it super easy for us to render and unmount components based on state. So persisting keyboard focus from state to state is absolutely critical. And just to really drive the point home, let's take one more look at what it took for us to build out our accessible button. We needed to add ARIA attributes in it, and we needed to manage keyboard focus. It was a whole lot of work, but technically we were able to do it. But what we really want to consider is the fact that there's already an HTML element that does all of this for us. We didn't actually have to do this, and I'm sure there are reasons why you would need a button that you just build out of a div, but if at all possible, make sure that you're always defaulting to the HTML elements that are available to you. And this is one way that we can very easily start to consider how we can build out our accessible components. Go ahead and take that one tiny step, find out where you're using something like a div button, and convert it to a regular HTML button. And that way, our components can, little by little, start to become more accessible. So I realize I threw a lot at you, so I'm going to do a very quick recap. We have 3 steps, for the most part, that we should keep in mind when we're building our components. We want to use Semantic HTML whenever possible. We also want to identify which ARIA attributes we might need within reason, but always be careful. And we have to make sure that we're managing our keyboard navigation. And we can uncover all of these requirements from the official documentation once we know where to look and what we're looking for. And again, I want to reiterate that these are just techniques to hopefully make accessible components easier. They're, again, not a magical solution, and they are certainly not the only things that we have to consider, because there are a lot of other factors that we need to weigh when we're building out our accessible websites and accessible components. We have to make sure that our visual design is accessible and ask ourselves if we're meeting the requirements for, let's say, color contrast, and see if we are building out color schemes that will be accessible for folks with different kinds of color blindness. We have to ask ourselves, will our single-page application that relies on JavaScript in the browser still work if a user doesn't have JavaScript enabled? And have we worked out how navigation between pages that uses client-side navigation, something like React Router, how will that affect screen readers and keyboard navigation? And we also want to make sure that we're writing unit, integration, and end-to-end tests that check to make sure we aren't breaking accessibility support with each change to our components. And is there a way that we can automate accessibility testing and integrate it into our CI/CD pipeline so that it's considered at every stage of the development cycle, excuse me. And most importantly, we want to make sure that we're considering our user. Sometimes as engineers, we tend to think that we know exactly what our users need. We tend to think that we have the right solution for everything, but in actuality, we may not know what our users need. And I want to point this out. There's an amazing post on the Gatsby blog, written by Marcy Sutton, and I encourage everybody to read it because it's a really incredible reminder that we can't always assume that we know what's best for our users. The blog post details how Gatsby did various rounds of user testing so that they could figure out how users with disabilities were navigating the web while using single-page applications. So let's always remember that our users are our #1 priority because we should always strive to keep the web inclusive and universal in order to do right by them. Thank you.